This is Lesson 7, Multiplying Fractions. Before we even get into any visuals, I want you to think about what you might have learned before if you learned about multiplying fractions. What you probably learned either from a teacher or from the textbook was to multiply two fractions, you multiply the numerators and you multiply the denominators. For example, if I was going to multiply 2/5 times 3/7, I would get 6/35. Before we even start, I want you to think about what you know from previous lessons that would tell you why you multiply numerators and denominators. So stop the tape, have some thought about why we do it that way, and then come on back and we'll discuss it. Hopefully you remember that in lesson 1 we said that multiplication, we always multiply digit times digit and place value times place value. And when we learned about fractions, we said that the denominator was the place value and the numerator was the digit. So as the visual shows, it makes sense that we multiply 2 times 3 to get 6, 5 times 7 to get 35, because we multiply digit times digit and place value times place value. Thus, when the question was asked before, 2 times 3 is 6, in what place value? You put the 6 here, the 6 is in the 35th place, 6/35. And then, of course, what we should do is check to see if we can reduce that fraction. Well, 2 divides 6, but does not divide 35. 3 divides 6, but does not divide 35. And in fact, the only number to divide 6 and 35 is 1, so we don't have to reduce. Now, we're about to see how something else we know about multiplication that is true for whole numbers helps us in multiplying fractions. The next problem shows us 6/25 times 10/21. And we can see that we're going to multiply top times top and bottom times bottom and get 60/525. But then we need to reduce, recognizing that both numbers end in 0 or 5 and therefore can be divided by 5. We do that and get 12/105. Then we recognize that by adding the digits, both numbers can be divided by 3, and we divide by 3 top and bottom and get 4/35. But look at the numbers in that problem. Fairly large, 60/525. It'd be nice if we could make the numbers smaller before we even multiply. And something we know about multiplication will help us. So if you look at the next visual, we are asked a question. 6/25 times 10/21. Is that equal? Notice there's a question mark over the equal sign. Is that equal to 6/21 times 10/25? If it is, why is it? If it isn't, why is it not? Stop the tape, think about it, and come on back and we'll discuss it. The one thing we know about multiplying numbers, whole numbers, fractions, or anything else we can multiply, is that it doesn't make a difference the order in which we multiply. 7 times 2 is the same as 2 times 7. So notice all we've done in that problem is we've reversed the order of the denominators. We take the 21 in the first fraction and move the 25 to the denominator in the second fraction. So the answer is yes, those two multiplication problems are equal, because in both cases the answer is 60/525. But notice what we can do. We can reduce 6/21 by dividing top and bottom by 3 and getting 2/7. We can reduce 10/25 by dividing top and bottom by 5 and getting 2/5. Now when we multiply, we get 4/35. By doing something called reducing our fractions, we have avoided reducing after we've multiplied. We're no longer dealing with those very, very large numbers. Well, every time we multiply, we don't have to be swapping numerators and denominators. There's an even easier way to do that, which is in the next visual. And that shows us something called canceling. Canceling really is a form of reducing. What we see, we have 6/25 times 10/21, and we look to see if there's a number that divides one numerator and one of the denominators. We see a 6 in one numerator, a 21 in the other denominator, and recognizing that we can divide by 3, we cancel. We divide 6 by 3 and 21 by 3, thus getting the 2 and the 7. We look at the other numerator and the other denominator, we see that both can be divided by 5. And we do that. Okay? Now, we multiply. So we've saved that step of swapping numerators or denominators and made the problem very simple. Now, can we always cancel? Of course not. Sometimes we can cancel both fractions, as we did here. Sometimes only one numerator and one denominator will cancel. And sometimes we cannot cancel at all. But let me say this. If we cancel completely, then the answer we get will not have to be reduced. If we cancel completely. Now, if you forget to cancel or you miss seeing someplace where you can cancel, that's not the end of the world. It's no different than we said yesterday, or whenever you watch the tape on adding and subtracting fractions. If we don't use the lowest common denominator, it's not the end of the world. Same thing here. If you do not cancel, it's not the end of the world. But you'll be working with larger numbers, and you'll have to check to see if you can reduce. So cancel when you can. Well, now, we're not always going to be multiplying simple fractions. Sometimes we need to multiply mixed numbers. Okay. If I was multiplying two mixed numbers, let's say 4 3/5 by 6 3/7, why could I not simply multiply the 4 times the 6 and then the fraction 3/5 times 3/7? And that would be my answer. When we added whole numbers and whole numbers, and the fractions and fractions. Why not do the same thing with multiplying? Well, I'd like you to stop and think about that, and then come back to the tape when you've thought about it, and we'll discuss why you can't do that. Well, we can't do that because when we multiply, each part of each number is multiplied by each part of the other number. If I was multiplying 42 times 37, I just wouldn't multiply the ones place digit by the ones place digit and the tens place digit by the tens place digit. I have to multiply each part of the two numbers by the other parts of the other number. So let's see. What would I do? One way to do it, as the next visual shows, is to simply multiply the 4 times the 6, the 4 times the 3/7, the 3/5 times the 6, and the 3/5 times the 3/7. And what we get is a long-winded addition problem. 4 times 6 plus 4 times 3/7 plus 3/5 times 6 plus 3/5 times 3/7. That is a lot of work. And it's unnecessary. It's really unnecessary because of one thing we learned in the lesson when we introduced fractions. We talked about changing a mixed number to an improper fraction. That was the last item we had to learn in that particular lesson. Here is where we'll use that. We will take the mixed numbers and change them into improper fractions. Because once we have two fractions to multiply, we know what to do. So let's take a look at the problem. If the 4 3/5 becomes 23/5, the 6 3/7 becomes 45/7. Before we multiply, we see if we can cancel. Is there a number that divides 23 and 7? No, there's not. There's no number that divides 23 except 1 and 23, so we cannot cancel there. But notice we can cancel the 45 and the 5. Both of those numbers are divisible by 5. We cancel, we get 9 and 1. And then we multiply across. 23 times 9. Well, 207 is a fairly large number, but if we had to multiply 45 times 23, that's a much, much larger number. And of course, 1 times 7 is 7. We wind up with the improper fraction, 207/7. Are we finished? Absolutely not. We cannot leave an answer as an improper fraction. Again, it's harder to understand. So we go to our simplifying process. We divide 7 into 207. We get 29 with a remainder of 4. So our final answer is 29 4/7. Now, one thing we need to do in multiplying fractions, because we're changing the mixed numbers to fractions and in multiplying and canceling, we need to estimate. It's really important. If you remember in the adding and subtracting lessons, we didn't talk much about estimation. And the reason is most of those problems, the numbers you're dealing with are relatively simple. If you have 4 in a fraction plus 5 in a fraction, the answer is going to be 9 or 10, depending whether you have to simplify because you have an improper fraction in your answer. But in multiplication, it's very possible to make a small error that leads to a large error in your answer. So what I like to do is say, look, 4 3/5 is between 4 and 5. 6 3/7 is between 6 and 7. If I multiplied 4 times 6, I'd get 24. If I multiplied 5 times 7, I'd get 35. What that means is that my answer should be between 24 and 35. If my answer was less than 24, I'd know it was wrong. If my answer was more than 35, I know it was wrong. My answer was 29 and 4/7, which is in between. That doesn't guarantee that my answer is correct. What it means is that I'm in the ballpark. And since everything I did I believe was correct, this should be the right answer. So this kind of checking by estimation doesn't tell you you have the right answer, but it will alert you if you have an obviously wrong answer. The only way to get the right answer, of course, is to do it carefully. Okay? And later on, in Lesson 11, we'll see how to check a problem like this on the calculator. Okay. Well, let's take a look at the steps in multiplying fractions or mixed numbers. The first step is to change the numbers to fractions. Because once we change it to fractions, then we can deal with all the other steps. We don't have to worry about multiplying various parts of numbers. Cancel if possible. If possible, because we cannot always cancel, because sometimes we have numbers that cannot be reduced. Multiply, numerator times numerator, denominator times denominator. And you know why we do that. I may ask you about that later on. The fourth step is to simplify, if needed. Sometimes we'll multiply and actually get a fraction, a proper fraction, 5/8. There's no need to simplify that. But if it's an improper fraction, we must simplify, again, to communicate our answer most effectively. And finally, check using our estimate. Estimate what the answer should be between, and then check that your answer falls in that interval. And if it does, at least you know you're not terribly wrong. And again, if you've done the work correctly, your answer probably is right. I'm really always concerned about knowing if I'm wrong. Knowing that you're wrong is more important than being right. So if I know I'm drastically wrong, I can go back and check. If I'm close, at least I'm close. In some kinds, close is good. Okay, let's take a look at a problem. This is a problem I'd like you to do. If you need to, go back to the visual that showed the steps. If you haven't written them down, write them down and then work this problem. The problem is 7 1/7 times 5 5/6. Go ahead and work that problem. Stop the tape, and when you're finished, come on back and we'll work it together. Okay, let's see. The first thing we want to do is to change 7 1/7 to a fraction. That's 57ths. Then we're going to change 5 5/6 to a fraction. That's 35/6. The next step is to cancel. Notice we canceled the 50 and the 6 because they're both even numbers we divided by 2. We have 25 and 3. 7 and 35 can be divided by 7, and we did that. We canceled and got 1 and 5. Then we multiplied across. 25 times 5 is 125. 1 times 3 is 3. 125 thirds is an improper fraction, so we simplify. We get 41 and 2/3. And finally, we check our answer. 7 times 5 is 35. 8 times 6 is 48. Is our answer between 35 and 48? I believe so. 41 and 2/3 is in that correct interval, and I believe it is the correct answer. Okay. Sometimes when we multiply, we don't have two mixed numbers. Sometimes we'll have a mixed number and a fraction. So the next problem shows us 5/8 times 3 1/3. And notice what we do. We changed the 3 1/3 to a fraction. We didn't change the 5/8 because it already is a fraction. 3 1/3 is 10/3. We cancel, as shown. We multiply numerator times numerator, denominator times denominator. We get 25/12, which of course is improper, and therefore we simplify to 2 1/12. Now, how would we estimate there? Well, when multiplying by a proper fraction, you always get an answer that's smaller, that's less than the other number. So I'm expecting by multiplying by 5/8 to get an answer that's less than 3 1/3. Some of my students like to say, well, let's see, 5/8 is between 0 and 1. So we use the same method we used before. 0 times 3 is 0, and 1 times 4 is 4, and therefore our answer should be between 0 and 4. Of course, 2 1/12 is. So whether you want to use that or just simply say that when I multiply by a proper fraction, the answer will be less than the second number. Either way, 2 1/12 is correct. The next problem shows us Another situation where we're multiplying a mixed number by a whole number. The first step is still the same. Change the numbers to fractions. Well, the question is, how do you change a whole number to a fraction? Well, remember that the denominator is the place value. And if we have the number 6, what's the place value 6 is in? Well, it's 6 ones. So that's what you do, 6 over 1. It's now a fraction. It's an improper fraction, but it is a fraction. And, of course, we multiply 6 over 1 by 14 over 8. I'm sorry, 35 over 8. 35 over 8, which is 4 3/8. And now we can cancel. We can cancel the 6 and the 8. Both are even numbers. We obviously cannot cancel the 35 and the 1, since the only number that divides 1 is 1. We multiply across and get 105 fourths. We simplify to 26 and 1/4. Let's see, estimation. Well, 6 times 4 is 24. 6 times 5 is 30. So our answer has to be between 24 and 30, and of course, 26 and 1/4 is. So our estimation shows us that our answer is in the ballpark, and of course, we've done our work correctly. It's the right answer. There is another way to do this, and if you find this second method a little confusing, disregard it. But you may find the second method makes more sense and is easier to do than the first method, and that is, what we do is, since we only have a fraction in one of the numbers, we multiply the whole number 6 by 4, and we multiply the whole number 6 by the fraction 3/8. That's really easy to do. 6 times 4 is 24. 6 times 3/8, again, we change 6 to 6 over 1. We cancel, and we get 9/4, which is 2 1/4. So 24 plus 2 1/4 is 26 1/4. For many fractional problems, when one of the numbers you're multiplying is a whole number, this is an effective way to get the correct answer. But that I'll leave up to you. I truly prefer the first method because it's consistent. Every time we multiply numbers that involve fractions, we do the same steps. And if we do it that way, again, the consistency leads us to correct answers. Okay? Let's take a look at one more type of problem, and then we're going to go ahead and work some problems, give you a chance to show that you understand what you're doing. This last kind of problem involves 3 mixed numbers. Now, there's really no limit to how many numbers you can multiply, but I thought, okay, let's take a look at 3, because sometimes in some textbooks they have problems with 3 mixed numbers, and sometimes people say, oh, I can't do it, that's too difficult. Oh, no. Hey, it's the same process. And actually, for some people, it's more fun. You have more chance to cancel. So let's take a look at this problem. We have 5 1/3 times 2 1/8 times 4 1/2. And we change the mixed numbers to fractions. First step is the same. We get 16 thirds, 17 eighths, and 9 halves. And now we cancel. And we can cancel any numerator with any denominator. So, for example, we cancel the 16 and the 8. And we get 2 and 1. But we notice that we can cancel that 2 in the numerator of the first fraction with the 2 in the denominator of the third fraction. And we do that, and we get 1 and 1. So, in effect, we've eliminated quite a bit of large numbers there. We also recognize that the 9 in the numerator of the third fraction and the 3 in the denominator of the first fraction can be reduced or canceled by dividing by 3. And ultimately, what we get is 51 over 1. Now, of course, that's an improper fraction, but really easy to simplify. That just says 51 ones. Well, that's 51. And the whole number, of course, is 51. By the way, we could estimate here, of course, 5 times 2 is 10, and 10 times 4 is 40, so our number must be more than 40. 6 times 3 is 18, times 5 times 18 is 90, so our answer must be between 40 and 90, and of course 51 certainly is, so it appears to be the correct answer. So you'll notice we use the exact same process. Now let's review that process one more time. The first thing we do is we take each of the numbers and change them into fractions. If the number already is a fraction, leave it alone. If it's a whole number, put the whole number over 1. If it's a mixed number, then change it to a fraction. If you've forgotten how to do that, go back to the lesson on the introduction to fractions, and you'll see how to do that. The second step is to cancel. You can cancel any numerator with any denominator in a multiplication problem, provided that there's a number that divides those two numbers. Third, multiply. Numerator times numerator denominator times denominator. If there are three fractions, numerator times numerator times numerator, denominator times denominator times denominator. Okay? If you get an improper fraction, simplify. Obviously, if you get a proper fraction, that's fine. And then check using estimation to see that your answer is reasonable. Notice there is no step called reduce. That's because I'm assuming that you are canceling completely. If you feel that, well, you might not always recognize when you can cancel, then always check to see if you can reduce. Okay? Now let's see if you can do some problems. Let's go to the whiteboard and examine some exercises multiplying fractional numbers. Okay? The first problem is 7 1/7 times 7/8. So we have a mixed number times a fraction. Okay? Why don't you go ahead and stop the tape, use the process to multiply these numbers, get your answer, check it for reasonableness, and come on back and we'll work the problem here on the whiteboard. Okay, we need the first step is to change the numbers to fractions. Well, 7/8 does not need to be changed to a fraction. It already is one. But 7 1/7, let's see, 7 times 7 is 49, plus 1 is 50/7 times 7/8. The second step is to cancel. Is there a number that divides 50 and 8? Well, yes, they're both even numbers, so they're divisible by 2. 25 and 4. And I cannot cancel 25 and 4 any further. Is there a number to divide 7 and 7? Well, obviously, yes, 7. So I can cancel, and I get 1 and 1. And now I multiply across. Numerator times numerator, 25. Denominator times denominator, 4. Improper fraction, so I need to simplify. 4 divides into 25 6 times. With 1 left over, 6 1/4. Now I need to go back to an estimation to see if this number makes sense. Well, let's see. 7 times 0 is 0. 8 times 1 is 8. So my answer has to be between 0 and 8. I also know, since I'm multiplying by 7/8, a fraction, a proper fraction, my answer has to be less than 7 1/7. 6 1/4 meets both specifications. It's certainly less than 7 1/7, and it is between 0 and 8. Okay, did you get that right? If you did not get it right, go back, be sure you've written down the 5-step process, work the problem again, and come back to this part of the tape to check your work. But we're going to go on and do another problem. Okay, the next problem is 9 1/3 times 3 1/7. Again, same process, work the problem, then turn the tape back on and we'll go over it together. Okay, let's see. The first step, as always, change the mixed numbers to fractions. Well, let's see. 3 times 9 is 27. 1 is 28/3. 7 times 3 is 21, plus 1 is 22/7. Okay. Can we cancel 28 and 7? Absolutely. 28 is in the 7 times tables, as we used to say. We can divide by 7. We get 4 and 1. How about 3 and 22? Well, you know the only number that divides 3 other than 1 is 3. Can 22 be divided by 3? Nope. Why not? Because 2 plus 2 is 4. And remember, if a number can be divided by 3, when we add the digits, we'll eventually get 3, 6, or 9. So that's it. We multiply across. We get 88 over 3. Okay, let's see. Improper fraction, we need to simplify. 3 goes into 88 29 times. And you'll notice we can't do fractions if we can't do whole numbers. If you can't add, subtract, multiply, and divide whole numbers, it's really tough doing fractions. For example, dividing 3 into 88. If you can't do that, you're kind of stuck with 88/3, which is not a complete answer. Let's see, we have a remainder of 1, so that's 29 1/3. Now we need to check. Well, 9 times 3 is 27. 10 times 4 is 40. So our answer should be between 27 and 40. Certainly 29 and 1/3 qualifies, and it is the correct answer. Okay, let's try another problem. Let's try one of those problems with the 3 numbers, just to see if you enjoy it as much as I do. 3 1/2 times 2 1/7 times 5 1/5. Now, there's nothing special about the fact that all 3 fractions have a numerator of 1. This is the problem I came up with for you to play with. So turn the tape off, work the problem, and come on back when you're done. Okay? First thing we need to do, change the mixed numbers to fractions. See, 3 1/2 is 7/2. 2 1/7, it's 15/7. 5 1/5, 26/5. And notice, we have 3 numbers, but we don't get upset because they're more than 2. We just take them one at a time. If we do that throughout mathematics, I think you'll find that the answers will be more easy to obtain. Can we cancel? Well, I think so. I see a 7 here and a 7 there. I can cancel those 7s, leaving 1s. I see a 5 and a 15. Divide by 5. Let's see, that's 3 times 5 is 15. 2 and 26 are both even. Divide. And I get 13. 1 times 3 times 13 is 39 over 1. And of course, whenever I have a 1 in the denominator, it means I have a whole number. So the answer is 39. Does that make sense? Well, let's see. 3 times 2 is 6. 6 times 5 is 30. So the answer must be more than 30. 39 is more than 30. 4 times 3 is 12. 12 times 6 is 72. The answer must be less than 72. 39 is less than 72. So I believe that 39 is a reasonable answer. And if it's a reasonable answer, then since I think my work is correct, I believe I'm right. And of course, 39 is the correct answer. So I think you can see that these problems aren't very difficult, and multiplying fractions for some people is a difficult area. And of course, if you understand the basis that multiplication is always digit times digit and place value times place value, then what we do when we multiply numbers involving fractions is quite simple, almost childish. The whole idea is to, again, have confidence in what you're doing. And one of the ways to build that confidence is to use a consistent set of steps, consistent procedure. And we were very consistent. The first thing we did was to change any number that was not a fraction to a fraction. Mixed number to a fraction, whole number to a fraction by putting the whole number over 1. Then we cancel using our knowledge of reducing fractions by dividing a numerator and a denominator by the same number until we could no longer cancel. Then we multiplied numerators and denominators. Again, digit times digit, place value times place value. Once we had an answer, if it was an improper fraction, we simplified, changing it into either a whole number or a mixed number. And then we went back and used our estimation skills to ensure that our answer was where it should be. There was not an obviously incorrect answer. And then knowing we did our work correctly would make us believe our answer was correct. Well, we're ready for the last fractional skill, which is division. And that'll be lesson 8, when we learn to divide fractions and review all of our work with fractions. See you then.